Okay, so in this video, I'm going to be working on problem 1 of Precept 6. So what we need to be doing here is we need to be repeatedly fitting a model on different training sets and observing how well the model works for both the training and the validation set. So the takeaway from this problem is that if your training set size is small, then your performance in the training set is going to be high. So the CCR, for example, is going to be high, but your performance on the validation set is not going to be as good. As the training set grows, the performance on the training set becomes a little bit worse, but the performance on the validation set becomes better. So we will be creating training sets of those sizes, right? So like 6, 7, 8, and so on. So let me just copy that. So the usual situation is that what you're doing is you are creating a training set like that and a validation set like that and a test set like that. And usually the split is like 70% train, 15% validation, 15% test for like reasonably small tests, reasonably small data set sizes. If it's pretty large, then it might be a little bit different. So basically, you always want more data in your training set, but you can't really use more than like a couple thousand rows in the testing and the validation set. So, okay, so those are going to be our sizes. So the way I'm going to do it is I'm going to say, I'm going to pick, so I don't really need a test set here. I'll just do like a validation set, and that's going to be 501 to 887. So 887 is the size of the Titanic data frame. Okay. And I'll create my train IDX, and I'll be creating training sets by selecting 6 and then 7 and then 8 and so on data points from the train IDX. Okay. So let me write a function. So the function will create a training set and of a given size, and then it will report the CCR on the training set that it created and on the validation set. Okay. So I'll call it train evaluate train size or something. So that's going to be function. So it needs the train size first because I'm going to be using sapply. So I'm going to be sending 6 here and 7 here and 8 here and so on. So we need train size, we need Titanic, we need train IDX, and we need valid IDX. Okay. So now inside this function, what we want to do is we want to create our train set. So I'll call it train IDX small. And though I'll do it, I'll say sample train IDX. So that just rearranges my train IDX. So this is the train IDX. So I just rearrange them differently every time. And then I'm just going to take 1 through train.size. So that's going to give me the, that's what's going to give me the indices for my small train IDX, because 1 through train size, and those are randomly selected indices from train.idx. Okay. So now I'm going to say, okay, so my train set is going to be Titanic train IDX small. My validation set is going to be the same every time. I could have sent it kind of to the function directly, but because I'm setting train IDX, I thought we might as well send valid IDX. So that's going to be valid IDX. We need, of course, a comma because we're selecting the rows from the Titanic, not the columns. So now we're ready to fit the model. So that's going to be fit. I'm going to say GLM. And we're predicting survived based on age and sex and P class, like so. So now we need to compute the CCR. So why don't I create like a separate function called CCR? So I'll give it the fit, and I'll give it the data. And then I'll say pred is, so I'm going to be making the predictions here. So I don't need to send the threshold. I just use 0.5 always. So I'll say predict fit, new data equals data, type equals response. And here I'll say greater than 0.5. So what this does is it's true if I'm guessing 1, if I'm guessing survived, it's 0 if I'm guessing did not survive, because this is the probability of survival. We're guessing will survive if the probability of survival is greater than 0.5. And now the CCR is just the mean of pred equals to data $survived, right? So this is a bunch of trues and falses, where trues correspond to a match between the prediction and survived, and falses correspond to no match between prediction and survived. So if you average that, you get the fraction of the trues in this vector of trues and falses. So I need my CCR on both the training and the validation set. So I'll just say C. I'll say here CCR fit train set. So here I neglected to say data equals to train set and family equals binomial. So fit train set, and I'll say CCR fit validation set. Okay, so that way I'm going to get the CCR on the training set and the CCR on the validation set. So now I'm breaking those up. So now I can say as applies. So I want to send this and this and this and this to train size, and then I want to send Titanic and training DX and validate DX. Those are always going to be the same. Those are never going to overlap because train IDX, I'm selecting a few samples from train IDX, and train IDX does not overlap valid IDX. So I'll say as apply X is equal to, so I'll say train sizes is this vector that was given to me. Say X is equal to train sizes, and I'll say fun is equal to train value of train size, and I'm going to give it Titanic equals Titanic, and train IDX equals train IDX, and valid IDX equals valid IDX. Seems a little bit long, so I'll just so now it's fine. So now I'll get my performances, hopefully. So let's see what happens. So here I'm sometimes getting an error. So this is factor P class has new level 2. So what happened here is that because the training set was so small, in the training set there weren't any passengers with P class equal to 2. And then when you try to predict for new data and you see P class equals to 2, R doesn't know what to do. So one reason for this is that I did this. So I treated class as categorical. If class were numerical, there wouldn't be a problem, because if you have a new value for class that's numerical, you just multiply it by the coefficient, so there is no problem. So let's just solve this problem by treating class as numerical. So you still see warnings. So fitted probabilities numerically 0 and 1. So what this means is that basically the situation is like this. So what R is trying to do, right, is it's trying to predict the probability of survived equals 1. And it's predicting it using sigma of A0 plus A1x1 and so on. So if one of those variables is categorical, it might be that everyone in the particular category, so for example, all the males in the training set survived. So then P of survived equals 1 for males, according to R, should be just equal to 1. But remember sigma, so the way you compute sigma is this, so 1 over 1 plus x minus z. So this thing, it can never exactly be equal to 1. Like, it doesn't matter what you make the z. It's never going to be equal to 1, because in order for it to be equal to 1, z has to be infinity, right? Because then x of minus z is going to be equal to 0, but z is never infinity. So R is trying to make sigma of this expression to be 1, but it can't. So that's why that's kind of what it's saying. So this is also like the reason that it does not converge, but we can kind of ignore it. It's still going to work. So this is what we got. So we have a performance of 100% on the training set for the small, and then goes to 57, 62, 88, 90, and so on. So our job next is to actually plot this. So let's create a data frame. So I'll call it perf for performance. So that's going to be data frame. So here what we have, this thing, let's call it perf mat for matrix. So I need to rerun it so that it's consistent with set seed equals 0. So perf mat is this matrix. We will have 2 rows. So we're going to say train is equal to the first row, right? So that's going to be perf mat 1, and valid is going to be perf mat 2. Okay, so that's this. So now we should start plotting it. So we'll plot it without using pivot longer first, and then we'll use pivot longer as well. So how to plot it? So I'll say ggplotperf. So I should probably also do like train size here. And that's just going to be train sizes. So I'll do ggplotperf, and now I'm going to do geomline. Yes, so here I'll say x is equal to train size. I'll say y is equal to train. And I'll add another thing. And here y is going to be equal to valid. Now, because we're saying train size both, so we can actually kind of factor it out, if you like, and say x is equal to train size both times. So now inside the geom line, we just need to say y equals train here and y equals valid here. Okay. So let's run this. So you get something like this. Now, so if we want to just have colors, we could say something like, so outside the mapping, but inside geom line, we could say color equals red. Okay, so that will make the train line be red. But this is not kind of the best, because that does not give us the possibility of having a legend. So to have a legend, here's what we'll do. So we'll assign colors like this. So we'll have a color that's corresponding to train, and that's going to be red. And we'll have a color that corresponds to valid, and that's going to be blue. So that's just how you do it. So this is what it looks like. So colors is a vector, but it's a named vector. So train corresponds to red, valid corresponds to blue. And now here we'll say color is equal to train, and color is equal to valid. Now, by itself, this is not going to work, because we did not make a connection between this vector and this. So we need to now make a connection. So you can do it with a scale color manual. And you could say values is colors. It is still unhappy. Here we're saying so that is because the color needs to be now inside the mapping, because now we need to actually look at the data. So before, kind of the color, like color equals red before, was just a property of how you display the line. But now, similarly to how you need to figure out kind of the height of the line by looking at the data at the Y, you'll now also need to look at the color from the data. So now it should be inside the mapping. So now we have this. We should also have labels. So we could say labs. So we could say it before color scale manual, after, doesn't matter. So we can say train set size is the X. And we can say performance or rate or something. So I'll say performance is the Y. And we'll say that the color, so this thing should be called legend. So, okay. So now that's this. And what you see is that for small train set sizes, you have very high performances, some of the time at least, for the training set. In part because like you get lucky and you get like a small training set that's easy to classify, but lower validation performances. And then after the training set size is after like 50, basically there is not anymore any overfitting and the performance is roughly the same. Okay, so now let's do part 2. So for part 2, what we'll do is the same thing. So we still have our perf data frame, but we want to transform it so that we don't have to bother with manually setting the color. So the perf data frame looks like this. And now we want to use pivot longer. So our goal here is to just have one data point per row. So one data point per row means that like in one row we have the 1, and in another row we'll have the 0.78. So that means that we need another column that will contain train and valid. Okay. So that's what we'll do with pivot longer. So the first thing that we specify is the names of the columns that we want to kind of collapse into one. So we'll say train and valid. So now we need to specify the name of the column into which like the train valid will go. So like we want one column that's going to say this one came from train, this one came from valid. So that's names 2, and we'll call it set for like validation set or train set. And finally, we want a column that's going to contain the performances. So like this stuff and this, this and this and this and this, that's all going to be one column. So that's going to go into performance. That's going to be values too. So if we do this, we'll get one column that's train and valid, and this is going to say from which of the train or valid columns that used to be in perf did the measurement come from. Train size remains unaffected because we did not mention it here. Okay, so let's call this perf long. Okay, so that's going to be like that. So now we get to try ggplot. So here we'll say perf long. And we'll say the mapping is, so the size is on the x-axis, right? So that's the size. The performance is on the y-axis. So we now, unlike here where we needed to specify the y twice, we just say y is performance. And we'll say color is equal to set. And now we can just do one geom line, and R is automatically going to figure out what to do because we set color equals set. So it's going to have two lines, one for the train, one for valid, as is usual when you can specify the mapping like that. So we need to save this. This did not quite go as expected. So let's see what's the problem here. So perf long is this. So this is train size. Yeah, so because we said size and not train size. So now it's fine, and you have kind of your axis and things like that. So if we want like a title, we can say train validation performance. For different train set sizes. And there you have it. So, okay. So now I want to do problem 3 from Precept 7. Actually, I'll do it in the next video.